What is up, everyone? Welcome back. Today, we're continuing our journey, practicing and continuing to learn how to solve quadratics by factoring. You're used to it by now. You know the drill. You're going to be taking notes on this lesson, and you are going to be submitting them on Canvas before the end of class. If not, you have until 11:59 p.m. tonight to get them in, right? You need an iPad or something to write with. Paper and pen works good too, right? Your factor chart is your BFF. Get that guy ready to go. And if you need it, access to a calculator is always granted. So, without further ado, let's jump into it, shall we? So, I've been putting these factor charts in your notes just so that it's here in case you don't have it or you want to refer back to it in case you lose it or something. It's always in here. So that's really great and awesome. Go me for doing that for you guys. But I want to do something a little different because at the end of yesterday's video, I had to skirt and change my mind. I could have kept going, but then I looked at the time and I was like, oh my goodness, it's short Wednesday. I had to abruptly stop. So this is out of the norm. But what I would like you to do right now is to go back to yesterday's notes. So if you're in OneNote, you just the one right above it, and scroll down to these problems. I said you don't have to stop after 8. You don't have to go any further. Let's stop right here. And I wanted to use problems 9 and 10 as a warm-up, and then you get to pick one of the problems to do on your own for 11 and 12. And then 13, 14, 15, 16, you get to choose 2 out of those 4. But I decided I want to do one of them with you. Then we'll continue with day 2. There's still factoring. It's still solving by factoring. I just wanted to make sure we covered these problems because they're really cool. And we're getting so much stronger and better and wiser and whatever that song says. So let's go back to yesterday's notes. We have x squared minus 8x equals 0 for our very first problem. Now, something I want to remind you of is when we were discovering how to use Xbox to help us factor, there were always 2 questions at the top of our page. Question number 1 said, is A negative? And question number 2 said, is there a GCF? So I want to consider those questions every single time. I want to make sure that we do not forget those, right? So looking at problem number 8, is A negative? No, it is not. Okay, easy. Move on to question number 2. Does it have a greatest common factor? And the answer is yes. X squared minus 8x, if I think about it, they have a GCF of x, right? X squared is x times x. Negative 8x is negative 8 times x. Hello, they share an x in common. So the GCF is x. From when we were doing this, we are always extracting the GCF out. Whether it's in the box, whether it's right here, we are going to take out x from our expression. And what's really cool when you're factoring out a GCF, if you write it multiplied like I did, what's left behind goes inside the parentheses. So that leftover x from earlier, they're going right inside the parentheses. This minus 8 going right inside the parentheses. What? And then you want to know what's even crazier? I'm ready to start solving. What? Step 1 of solving by factoring is set the equation equal to 0. Step 2 says factor. We just factored. Factoring the greatest common factor out. It literally says factor. We factored it. Now we're ready for step 3, fam. All right, can you believe this? How cool. I did not need Xbox. I don't actually need Xbox every time. I just really like it. I think it's a really awesome strategy, and I highly, highly encourage it, but it's not necessary. Some of you might have started noticing patterns of factoring anyway, specific to the way that we're setting it up, the way that we're solving. And so if something else you're noticing in your brain is working for you and you don't need Xbox anymore, by all means, do your best. What I love about Xbox is it's familiar. You check yourself so you know whether you got the thing correct or not. And it's just very satisfying. But yeah, we're already here. We are factored. X times x minus 8. Remember, parentheses mean multiply. Right? We have factored the expression. We have broken it into pieces that multiply together, just like a Kit Kat bar. So now we're ready for step 3. Set each factor equal to 0. You might be thinking, Ms. Passmore, that little x out there, that's not a factor. Yes, sirree, it is. And it's already done. X equals 0. Boom. I got my answer. I also need to set x minus 8 equal to 0. And I would get 2 solutions. X is 0 and x is 8. So step 1, set your equation equal to 0. Step 2, factor it. Step 3, set both factors equal to 0. And step 4, solve for x. Boom. Wasn't this a cool example? I'm living. Let's do number 10. Same idea. Question number 1. Is a negative? A's 3. No, it ain't negative. So question number 2, is there a greatest common factor? 3x squared can be thought as 3 times x times x. 15 is like 3 times 5 times x. Oh my goodness. They share a 3. They also share an x. So my GCF is 3x. You already know we're going to take 3x out of the equation. We're literally going to factor it out. What's left behind is x. Left behind, positive 5x. Boom. Step 1 and step 2 done. So the equation equal to 0. Factor it. Now we're ready to set each factor equal to 0. I'm so silly. Sorry. It should have just been 5 here. My mistake. Whoopsie. I was like, x plus 5x. That's weird. Found my mistake. Set each factor equal to 0 and solve. We're literally so close. We're almost done. This is why solving by factoring is nice. Once you get into the groove and you're starting to feel confident in it, it's really just a pattern. And if you repeat the pattern, you're going to be able to solve so quickly and know that you did it right. For 3x equals 0, we need to divide by 3, friends. Remember, it is okay to have 0 on top. You just get x as 0. If I had nothing and divided it by 3, I still have nothing. And if you're not convinced, please use your calculator to verify. You will feel so satisfied. Remember, you can always have access to that thing. X plus 5 equals 0. I'm just gonna take away 5 on both sides, you know? Here we are. X equals negative 5. What? Donezo. Step 1, set your equation equal to 0. That was done for us. Thank you so much. Step 2, factor it. Step 3, set each factor equal to 0. Step 4, solve. You get to pick either number 11 or number 12. Please pause this video, come back, and I'm going to reveal the answers, and I want you to engage in a little self-reflection and think, did I get it right? Did I get it wrong? And if you got it right, give yourself a pat on the back. If you got it wrong, I want you to pause the video again, and using the answers, go back and see if you can get the correct ones. Okay, so a little bit of a challenge built into here. Pause me, try one, see if you got it right. If you didn't get it right, pause it again and rework the problem, see if you can find and fix your mistake. Okay, we're back. Hopefully you solved either 11 or 12. If you solved problem number 11, you should have gotten x equals 0 and x equals 2 as your solutions. Either give yourself a pat on the back or figure out where you made a mistake. And for problem 12 is a little tricky. You should have gotten x equals 0 and x equals 3 over 4. What? If you hate fractions, you totally could have said that this is equal to 0.75. Those are the same things, right? But I don't know if you guys remember, but when we first started talking about solving by factoring, I showed you the answers first. and we looked at it and we're like noticing and wondering things that we could get, one of the problems you could have gotten a fraction. And so this is our first fraction answer. How fun! Okay, we're going to move on to problems 13, 14, 15, and 16. And although, quick glance, they look to be the same as the last problems we just did, because they have two pieces, right? If I think about it, like this problem had two pieces, x squared minus 8x. This problem had two pieces, 3x squared plus 15x. This had two pieces, 6x squared minus 12x. This had two pieces, 8x squared minus 6x. And all of these, 2, 2, 2, 2. However, this is x squared in a number, x squared in a number, x squared in a number, x squared in a number. These were x squareds and x's, x squareds and x's, x squareds and x's, x squareds and x's. So the strategy is going to differ slightly. And there's a really cool pattern in these four problems here. I want to challenge you to see if you can find the pattern, okay? And I'm actually going to do 16 for you because I think we should do hard things together, you know? It's not that crazy, it's just, it's a little different. So, question 1, is A negative? 9x squared minus 49. Is A negative? No, it ain't. So, we're good. Question 2, is there a greatest common factor between 9x squared and 49? Well, 9 is 1 times 9 and 3 times 3. 49 is 1 times 48, 2 times 24, 3 times 16, 4 times 12, and 6 times 8. So they actually do have a greatest common factor of 3. So let's go ahead and do that. I can also, something really cool before doing the GCF, right? So we can see the GCF is 3, right? Because this is 3 times 3 and then x times x, 49. I was able to do 49. Oh, I was looking at, I was looking at the wrong things. 49 is 1 times 49 or 7 times 7. Just kidding. No GCF. The GCF is not 3. Skirt. JK LOL. Perfect. Because I spy with my little eye a cool pattern. Okay. So check this out. It's not a GCF, but is this not awesome? You can think of 9x squared as like 3x times 3x. And 49 is 7 times 7. Well, it's actually negative 49, so 7 times negative 7. What? This is a special type of problem that we covered already called the difference of squares. If I look at all the others, they have this same pattern. X squared, that's x times x. 25, that's 5 times negative 5. Well, negative 25. X squared minus 64, that's x times x. 64 is a perfect square as well. 8 times 8. And then one of them's negative. 4x squared is kind of the same, where it's 2x times 2x. 81 is 9 times 9, and one of them has to be negative. All of these problems have a minus sign in the center. That's where the difference comes in. And then they're perfect squares, so we call them of squares. Or I like to call them dose problems. They have a really cool pattern, and you can still use Xbox to solve them, but I'm going to challenge you to see. The Xbox is kind of funky a little bit for the difference of squares, but it still works. It still works. See if you notice something really cool that you can do without the Xbox in hindsight, and I encourage you to use that strategy when you choose to solve. But alas, without further ado, let's go back to what we know. Let's go back to what we're comfortable with, which is Xbox. So A is not negative. There is no greatest common factor. So we're going to go to make X. That is A times C. This is icky. 9 times negative 49 is negative 441. And before you freak out, pump the brakes. Remember that there's nothing in the middle. So I need two numbers that multiply to negative 441, but they add up to 0. Since it's negative, I need one of them to be negative and one of them to be positive. And with a quick little calculator check to see if something's a factor, remember, you take 441 and divide another number. It is a factor if there is no decimal. I found out pretty quickly that 21 works. Negative 21 and positive 21. Do you see why I picked 16? The numbers are just a little icky. After this, we have our x. Now we need our box. We're ready to build it. Inside our box goes the first term, 9x squared in the first box. In the last box, minus 49. What I found from the x, negative 21x and positive 21x. Now we're ready to extract our greatest common factors from all parts. 9x squared and 21x have a greatest common factor of 3x. 21x and negative 49 have a greatest common factor of 7x, or just 7, sorry. 9x squared and 21x have a greatest common factor of 3x. Negative 21x and negative 49 have a negative 7 in common. Do not pass go. Do not collect $100. You must check your work first. 3x times 3x, that is 9x squared. Check. 3x times 7, that is 21x. Negative 7 times 3x is negative 21x. Negative 7 times positive 7 is negative 49. Yippee! Now we're ready to rewrite our 9x squared minus 49 in factored form. That is 3x minus 7, 3x plus 7. And it was set equal to 0. Step 1, set your equation equal to 0. It was done. Step 2, factor it. Step 3, set each factor equal to 0. Boom. Now all we need to do is get x alone. Remember, the directions say to solve. Get x equal to a number. With just a little bit of algebra, we get, ew, another ugly answer. X equals 7/3. What the heck? If you hate that, just know it's about 2.3. But fractions are nothing to be afraid of, guys. Sometimes things work out to be messy numbers. And honestly, that's life. Negative 7/3 or negative 2.3. What? We did it. Awesome. All right, so what we're gonna do is we're going to move into our actual notes for today. Pause this video, choose two numbers to solve, but we're gonna go back to today's notes. So get out of yesterday's notes, go back to today's notes. I'm so sorry about that. I really should have thought closer about this. But we're just gonna get into solving some equations that are not in standard form to start with. Notice that like our last couple, they were already set equal to 0. So here we're going to start with equations not in standard form to begin with, okay? Don't stress, don't freak out, everything is all good. But it's just one small step to get us going. So remember, step 1 of solving equations was to get it equal to 0. I just need to minus 21 on both sides to start. Then I have x squared plus 4x minus 21 equals 0. It's really important that we are putting our equations in standard form. Remember, that's ax squared plus bx plus c. Like the x squared and then the x and then the no x in that order, because otherwise Xbox gets really messy. So step 1, set your equation equal to 0. Step 2 is to factor it. A is positive. There's no greatest common factor here between 1, 4, and negative 21. So let's move into our x box. X squared, 1x squared times negative 21. Okay, negative 21, positive 4 goes down here. So I'm trying to find two numbers that multiply to give me 21, but they add up to 4, and there's only two numbers in 21, 1 and 21 and 3 and 7. So it's got to be 3 and 7, and we'll make 3 negative. Then we'll use the box. X squared and minus 21 goes in here. Negative 3x and positive 7x goes here. And now we're ready to extract the greatest common factors. We have x here. Whoops. We have 7 here. We have x here. We have negative 3. And let's check. X times x is x squared. X times 7 is 7x. Sorry, I used like the world's smallest box here. Negative 3 times x is negative 3x. Negative 3 times 7 is negative 21. Yay! Step 1, set your equation equal to 0. You might have to do a little algebra. Step 2, factor. This is x minus 3, x plus 7 equal to 0. Step 3, set each factor equal to 0. Step 4, get x alone. Boom. Done. How cool is that? Let's do another one, shall we? We're on a roll. X squared minus 45 equals 4x. All right, this 4x, sorry. You got to go, buddy. You got to move. Take away 4x. Whatever I do on one side, I do to the other. Remember, I want it in standard form. So I'm going to leave it as x squared minus 4x minus 45 equals 0. All right. Is A negative? No, it is not. Is there a greatest common factor? No, there is not, so I'm ready for X box. X is going to be 1x squared times negative 45, so it's negative 45. I need two numbers that multiply to negative 45 that add up to negative 4. Using our factor tree, we can see what this is going to look like. Uh, 45 and 4. So using my factor, that's going to be 5 and 9. And then one of them needs to be negative, and I need it to be negative 4, so I'm going to make the bigger one negative. All right, now we're ready to use our box. First value is x squared. Second value was minus 45, or the last value was minus 45. And I'm going to put 5x and 5x in here, and now I'm ready to factor out the GCF. This is going to give me x. This is going to give me 5. X squared and 5x is going to give me x. 5x and negative 45 is going to give me... Oh, I spy with my little eye a mistake. This one should have been, sorry. 5 and negative 9x. So when I factor the GCF out, 9, 18, 27, 36, 40, yeah, 9 goes into 45, so that would be negative 9, sorry. 5x and negative 45 is 5. Double check your work. I would have found my mistake just now in fitting in the X box if I checked my work, so that's why I'm telling you guys, always make sure we check our work. X times x is x squared. X times negative 9 is negative 9x. 5 times x is 5x. 5 times negative 9, negative 45. Perfect. So I can rewrite my x squared minus 4x minus 45 equation equal to it in factored form, which is x plus 5, x minus 9 equal to 0. Set each factor equal to 0 and solve. Whatever I do on one side, I do to the other. Boom. Again, steps to solve by factoring. Set the equation equal to 0. Factor the equation part. Set each of the two parentheses factors equal to 0. Get x alone. Solve. Sometimes we get pockets of problems that look different. So in 17 and 18, I just needed to move one thing over. You'll notice that in 20, there's two things that need to be moved over. And so you have a little bit of choice. Something really important is to make sure that x is always positive. Do you see how like this is positive x squared, positive x squared, positive x squared, positive x squared? At all costs, definitely try to keep that positive x squared. So in like a case like problem 21, you'll want to just minus x squared on both sides. And now you'll have 11x squared minus 1, so that's 10x squared equals 8x. And then you're like, wait a minute, I need to move this guy over too. Remember, we need everything equal to 0. So you have 10x squared minus 8x equals 0. A is not negative, but it does have a GCF. 10 and 8 are both even numbers, so they definitely have 2 in common. But is there a bigger one? 1 and 10, 2 and 5. No, that's it. So we're going to factor out our 2. And this is going to become 5x. Oh, no, it has an x too. I noticed this one has 2 x's and this has an x. So my GCF is 2x. It's going to leave 5x minus 4 equals 0. I don't know why I moved this way down here. And then that is factored form. Set each factor equal to 0 and solve them separately. You get x equals 0 for this guy. X equals 4 over 5 for this guy. And it's all good. Again, to recap the process, set your equation equal to 0. Factor it. Set each factor equal to 0 and solve them separately to get x is equal to a value, a number, a fraction, something where x is alone. For a problem like number 20, you can also just do it like this. I know in problem 21, I split them up. Just remember that whatever you do on one side of the equal sign, as long as you do it on the other, you're going to be good. So now I have x squared minus 14x. 49 minus 1 plus 48 is equal to 0. And that's my step 1. Step 2 is going to be to factor that expression. I can keep using Xbox, or you might start to notice a pattern. Nonetheless, I'm going to have you pause the video and try number 20 on your own. Go ahead and give it your best shot. All right. Interesting. I wonder if this was not on... It wasn't. Oh my goodness. Whoops. Okay, now I'm a big fat liar. Now we should be in today's actual notes. I'm so sorry. I don't know why. I think I misordered them. Deeply apologize, guys. This is kind of the same idea where we're solving quadratics by factoring on our own. Hopefully we're really warmed up by now. I mean, we've been at this for a hot minute. Is a negative, for example, 1? No, it's not. But is there a GCF? I do believe there is. 3 can be written as like 3 times x times x. 9 can be 3 times 3 times x. 12, 3 times negative 4. Right? They all definitely have 3 in common, so let's factor out that 3. That leaves me with 2 x's, so x squared, a positive 3x, and minus 4 equal to 0. And now what's different from this example is we factored out a greatest common factor, but we're not done. Do you see how there's 3 terms, x squared plus 3x minus 4? We got to factor that guy, and we can use Xbox to do it. 1x squared times negative 4 is negative 4. It's going to need to, 2 numbers are going to need to add up to 3. So I'm looking for 2 numbers that multiply to give me negative 4, but add up to give me 3. That's going to be 4 and 1. One of them's negative. 4 minus 1 is 3. Put it into the box. We've got x squared minus 4, 4x from the x, negative 1x. And we're ready to factor out the greatest common factors. X squared and 4x, those share an x. Negative 1x and negative 4 share a minus 1. X squared minus 1x share an x. 4x and negative 4 share a 4. Double check your work. X times x is x squared. X times negative 1 is negative 1x. 4 times x is 4x. 4 times negative 1, negative 4. All right, so now I can rewrite my expression in factored form. That 1x squared plus 3x minus 4 is x plus 4, x minus 1. Something super important. Do not forget this 3. He didn't just go away to nowhere. So step 1, set your equation equal to 0. Step 2, factor it fully. That's a new thing. Make sure it's factored all the way. Step 3, set each factor equal to 0. 3 equals 0. That's a liar. So we don't have to worry about that answer. 3 is not equal to 0. But it's really the ones with the x's. Set x plus 4 equal to 0. And upon solving, I find that x is negative 4. Set x plus 1 equal to 0. I get x is equal to 1. And I've completed my tasks for solving via factoring. Cool! We're going to do I'm going to pivot something just because this video is getting a little longer than I would like to. We're going to do one more example in these notes and leave the rest. And tomorrow's going to be a Delta Math day, so it's unaccompanied. Let's do example 2 and then call it a day for today. Turn in your notes, and tomorrow we'll be practicing with Delta Math. I put way too many examples, I think, guys, so I apologize about that. But just like I would do in class, if things go too long, we pivot. 5x squared minus 20x minus 60. There is a greatest common factor here of 5. Oops. So let's make sure we immediately take out the 5. That's going to leave x squared minus 4x. 60 is going to be divided by 5 is 12. And then I'm going to need to factor this guy within. So this is like factoring inception. It's like factoring within factoring, even though the only thing I've just done right now is the greatest common factor. So I need my x, I need my box. I got x squared minus 12 in here. And this is 1 times negative 12. So I'm looking for two numbers that multiply to negative 12, but they add up to negative 4. I believe that's going to be 6 and 2, my friend. One of them needs to be negative, though, and it's going to be negative 6, because negative 6 plus positive 2 is negative 4. Negative 6x, 2x, and now I'm ready to take out the GCF. X, 2, x, negative 6. Let's check. X times x, x squared, x times 2, 2x, negative 6 times x, negative 6x, negative 6 times positive 2, negative 12. Let's rewrite our equation, which was 5. Instead of that one big parentheses, I can break it into 2. X minus 6 and x plus 2. Now I'm ready to set each factor equal to 0. This is a lie, so it doesn't count. I get x equals 6. And x equals negative 2. Awesome. Thanks for hanging in there, guys. I know that this can get a little overwhelming and feel quite stressful, but just know that you don't have to have it 100% complete. I'm proud of you right now as it is. And I look forward to seeing how much progress we made. And remember, you can always watch these videos. If you're feeling stuck or you forgot when we go to study for the test, man, these videos are published on YouTube. I made them for you. So without further ado, we're going to stop here. You're not going to take any more notes. You're going to submit them on Canvas by 11:59 p.m. tonight. And tomorrow, I'm going to scroll all the way down. Tomorrow, we're going to practice via Delta Math problems so you can get that immediate gratification that you got this right since I won't be there. All right, guys, take care. See you soon.